When the deep field image from the James Webb Space Telescope made rounds on social media, millions of people around the globe fell in love with astronomy. But life's tough, isn't it? There's a lot going on that we can't fix yet. But Webb gave humanity a major win in July 2022. So in this video, we'll be taking a look at why it exists and what it means for our future. Let's dive in. First up, Webb had a really specific and really difficult job. When it launched on December 25th, 2021, Webb was meant to do four things: search for light from the very first stars and galaxies after the Big Bang, study galaxy formation, star and planet formation, and finally, to study how life itself forms on planets. They sound like simple goals, but they're far more difficult than that. See, when you're trying to peer into the earliest stages of the universe, you need more than visible light. Looking that far with a light detector would only show you a dark, empty space where galaxies should be. And as we've seen from the deep field image, space is anything but empty. It's teeming with light, explosions, and gorgeous colors. So how do you go about detecting something without visible light? Well, you switch to infrared. Now, we know what you're going to be thinking. Didn't Hubble's deep field do the same thing? Well, yes, technically it did, but Webb is far beyond that. So you've got an electromagnetic spectrum, right? From X-rays all the way to gamma rays. And in the middle, you have visible light, and then a band of infrared radiation. Hubble could only detect a small portion of this band, but Webb can detect nearly half of it. So what's the difficult bit? Well, detecting any form of infrared radiation means there's going to be some sort of heat involved. It's all based on temperature. Anything that has a temperature emits some form of infrared radiation, and that's why infrared cameras are able to pick up heat signatures of humans and vehicles, even if they try to hide. And this means that the surface of Webb's telescope needed to be really cold. We're talking near absolute zero temperatures. If it got any warmer, then the infrared radiation it emits would distort the results. And when you're a million miles from Earth, you're also at risk from the sun's radiation. But that's not even the most difficult part. The difficult part was figuring out how they're gonna get a giant telescope into space without folding it in half. When you need to scan deep space, you need a giant telescope to do it. Need more resolution on the Sombrero Galaxy? Well then, increase the surface area of the telescope. But the deeper and more clearly you want to peer into space, the larger your telescope needs to be. And eventually, you'll need one the size of the Earth. But hold on, how do you even get it to space in the first place? Well, the geniuses at NASA figured out a certain way to carefully unfold the telescope when it reached its location nearly 1 million miles away. And it had 344 individual points of failure. Wow, imagine if one of them randomly decided to fail. But Webb is overachieving. We're not kidding. It's like that kid Mark in high school who always gets a 100 on his test, even though he said that he didn't study at all. Sorry, flashbacks to 10th grade. Anyway, Webb's eagerness to perform comes from the fact that its mirrors are cleaner than scientists require to look into space. Even its guidance system, which helps it lock onto objects and tracks their movement, is better than expected. What's more, NASA expects that it has enough fuel on board to power its mission for 20 years. And launching Webb nearly 1 million miles away wasn't easy either. The idea of a next-generation telescope that could outdo Hubble came into existence way back in 1996, when NASA began developing the initial designs of Webb. Back then, it was named the Next Generation Space Telescope. And a quick side note, Star Trek fans would have loved that name, but we get it. James Webb Space Telescope sounds more formal, and of course pays tribute to the second administrator of NASA between 1961 and 68. The name had a bit of controversy too, but we'll get to that. Now, back in '99, NASA experts projected a 2007 launch and a $1 billion budget. But a lot of problems began plaguing the project. For starters, they grossly underestimated their budget. By the time it launched, it carried a mind-boggling $10 billion price tag, including monitoring and maintenance costs. And over the course of nearly 2 decades, over 20,000 people have worked day and night to bring Webb to life. But in 2005, after nearly a decade in design and development, it went through a major redesign. Just when folks at NASA thought they were ready for a 2007 launch, launch, it got delayed even further. In fact, the name made everything 1,000 times more difficult. Back in 2002, Sean O'Keefe, who was NASA's administrator at the time, decided to name the telescope after James E. Webb, who oversaw the Mercury, Gemini, and a lot of the Apollo programs. And this led to a major controversy in 2015. The media started buzzing that Webb had a role in the Lavender Scare. For those of you who don't know, it was a horrible moral panic across the US that gay people were working in the government. And this was way back in the late 40s and 50s. Nearly 300 US State Department officials were fired because of this. So you can imagine how bad it must have been. So what's James Webb's part in all of this? Well, he served as Undersecretary of State from 49 to 52. And so a lot of folks assumed he was a part of the Lavender Scare. In March 2021, 4 scientists published a piece in Scientific American and asked NASA to change the name of the telescope due to Webb's alleged complicity in the scare. There's an ongoing inquiry about it, but as of this video, there's no evidence that he was a part of it at all. In fact, Hakeem Oluseyi, a renowned astrophysicist, claimed that the accusations were based on a quote from Wikipedia that was falsely attributed to him. And even now, in August 2022, scientists and engineers around the world are kind of shocked at how something that was so high stakes, controversial, and complex ever launched into space. Now, 7 months after launch, the Webb telescope gave humanity what it needs. It's not just a win for NASA, the European Space Agency, or the Canadian Space Agency. It's a win for all of us as a collective. JWST is the largest telescope that we've ever launched into space. It pointed its mirrors to a SMACS 0723 in the constellation Volans and stared at it for 12.5 hours. NASA decoded the data, composed an image, and we got to see Webb's first deep field. And it was breathtaking. If you look at the image, you're looking at a cluster of galaxies that are 13.6 billion years old. And for context, the entire universe is just over 13.7 billion years old. So what we're looking at is a region of space where the earliest galaxies and stars exploded into existence. Plus, Webb's deep field is leagues ahead of Hubble's. There's no competition, if we're honest. And did you notice that a few bright objects had spikes? Well, that's how you can differentiate between an image from Webb versus an image from any other telescope. They're called diffraction spikes, and it has to do with the way the mirrors are set up. Hubble has 4 diffraction spikes, and Webb has 8. So that's a neat party trick for you, but Webb isn't done yet. It's got a lot more staring into space to do. In the next few months and years, we'll be getting far better looks into the depths of the universe. Webb's got 20 years worth of fuel left, so we assume NASA's going to use every drop until they can discover the actual Big Bang. That's what Webb is for. It's bigger than all of us. And in just a few short weeks, it's given us breathtaking views of the Carina Nebula, Stephan's Quintet, and the Ring Nebula. It showed us what we're actually capable of, and that was just the deep field. Just like Hubble's ultra deep field, we can expect something even more amazing in 2023. And lastly, the Webb telescope is our future. In a world where digital tools are used to create havoc and global warming is threatening to annihilate us, the Webb telescope offers us a glimpse at what we can be as a species. And it gives us hope. It shows us that space and the infinite mysteries it contains within itself is the final frontier. What if we find some ancient unknown civilization somewhere in SMACS 0723 or somewhere else? What if we see the first moments of the Big Bang in a future Webb image? And what if we finally see a clear image of a supermassive black hole or a supernova just as it's happening? There's so much mystery in space that we'd probably need a billion Webb telescopes just to scratch the surface. But hey, JWST was just the first step, and there's definitely more where that came from. And that's a wrap, folks. Thanks for watching. So with all the hubbub about JWST, what do you think it means for the future of astronomy? Will we ever get to see a glimpse of the Big Bang? Tell us your theories down in the comments. And as always, be sure to give us a massive thumbs up and subscribe to our channel for more exciting space stuff. Till next time.